purpose of this activity is to introduce us to Newton's second law. From the force of gravity activity, we found that the force of gravity was equal to the mass of an object times the acceleration of gravity. Then we figured out that that could be generalized, at least we assumed it could, that the force, any force, would be equal to the mass of the object times its acceleration. This turns out to be Newton's second law. And we're going to be using it a lot. The way it's usually actually written, this is the way I've always remembered it, and that's kind of how I've used it. Newton himself actually wrote that the acceleration of an object is equal to the force. Actually, it's the net force, which we're going to talk about in a minute. It's the net force on an object divided by the mass. That's Newton's second law, and that's what we're going to be looking at here in this lab. This is the big picture setup of our introduction to Newton's second law activity. We've got the track. We've got a pulley at the end. We have a string that's going to pull our cart with it has our force probe on there. I'll give you a close-up of that in a minute. And we have our LabQuest. It's all taped together. It's not real sturdy, so you have to be careful. In fact, make sure you do not set the cart on the table unattended, because it rolls really easy. That's why they call it a frictionless cart. So you need to make sure that you don't set it on the table, because if it's not level at all, it'll roll off and these things can break. Then we have a weight. I have a really small weight at the bottom that you can see here, and that's what we're going to use to provide our force to pull our cart. Here's the top view of the setup. We still have the ramp. You notice I have some cardboard. Some of these tracks are missing the little knobs on the end, so this one wasn't level. This slab is very sensitive, so you need to make sure it's level, and the way you tell is you set the cart on it and you just tap a little bit. If it doesn't start rolling one way or the other, then you can assume that it's level to the ground. And again, we're going to have our LabQuest up here, and the force probe will be underneath it, and the LabQuest will be hooked up like we've hooked it up before. Here's a quick close-up of the cart setup. Again, you can see that here's the probe. Notice all the wires are off the cart. If you've got extra strings, I'll try to get rid of those for this lab, but if you've got extra strings, make sure they're not under the wheel, because this is a really sensitive lab and it will affect it. The first thing the instructions say to do is to weigh the cart and everything with it. So you're going to have to weigh this entire thing on the scale to find the mass. And you can set your scales up. We'll have to share scales, but you can set them up to actually give you, you can find either the mass or the force they take. In this case, we'll need to find the mass. Then after you've got it weighed, you want to set it up. You want to zero it in this position. So as we learned before, you'll just tap on the red or tap on the sensors and zero your LabQuest. Then it says to find the minimum force it takes to make the cart move. In fact, if you notice, if you remember in the big picture, I'll show you again, just wait just a second. In this picture, I actually have a weight that is pulling on the cart, but the cart is not moving. That's because even though we call it a frictionless cart, this is real life and there is some friction. And the forces we're going to be using are small, so this force of friction will matter. So you need to figure out how hard it pulls, the minimum force required to make it move. So you can hang a really small weight and see if that makes it move. And you can pull on it a little bit and then look at the LabQuest at the top and estimate as best you can what the force is that will make the LabQuest move. So returning to this picture again, I'll read this number as best I can. You could use the green button if you really want to try to determine exactly what force made it move, but just do the best you can. Get the most accurate thing you can get, the most accurate force you can measure to when it starts to move. And the instructions say we're going to call that our force of friction. Then you're going to hang a weight like the previous picture showed. You're going to hang the next biggest weight on the string that will make the LabQuest move. So in my setup, I used just a roll of tape to keep it from moving until I was ready for it to move, and I'm going to go, it's hard to see here, but this is looks like 90 to 70. Doesn't matter what these numbers are, but we're going to go 20 centimeters. And again, I'm going to exaggerate the initial movement so that I can get an accurate time. So here's what it looked like. I jerked it away, and the goal was to find the time it took to move. Once you find the time it took to move these 20 centimeters, by now we should be able to calculate in our sleep what the cart's acceleration is, because you know the initial velocity. You don't need to know the final velocity if you have the time. And then you're going to put that value in the table, which I'm going to show you in a minute, in what your notebook should look like. You're going to put that value in the table, and you're going to have a table to all the first row of data that you calculate. I want to see all your work in detail. After that, if you want to just punch the numbers into your calculator, that's fine. Then you're going to record the acceleration and the mass in the table, and you're going to go all the way up to 100 grams. We're using light weights because if you put a heavy weight on here, the acceleration is so fast, your times are too short and it's hard to measure. Then after that, the instructions, you can just follow the instructions. You're going to generate an equation for the force and the acceleration and do some other activities. Now I'm going to show you what your lab notebook should look like. Here's what your lab notebook should look like. It should have a title, Introduction to Newton's Second Law Activity. The instructions say you're going to write down the minimum force, which I said you could call the force of friction, and we might as well get used to using the subscripts. F sub F would be the force of friction, and what I wrote in red is, I just made that up, that it was 0.1 newtons. That's what we measure force in. The mass that I have, my 0.02 mass, the 20 gram mass, was enough to get my cart moving. If that's doesn't move your cart, then you need to start at whichever mass will work and then go up by 10. So if you either start at 0.02 kilograms, or so it's 20 grams, 30 grams, wherever your cart starts to move, that's your first mass, and then you go up by 10 grams until you get to 0.09. I think the instructions say to go all the way up to 100, so there should be one more number in there. Then I calculated the force based on this mass. Actually, I didn't calculate. This is, you just read this off your LabQuest. This is the number you read off your LabQuest. Then in my work, I showed that I subtracted my force of friction, which is going to be the same every time. I subtracted that from my force that I read off my LabQuest, and that gives me my net force. Newton's second law only applies to net forces. If two people push on the opposite side of an object with the exact same force, it's not going to move. So this is the net force. So we now have the net force. I made up a time that I measured, and then from that time I used this equation, which we've done lots and lots of times because I know the initial velocity was 0. I find the acceleration, and I plug that value up here. And then I will repeat this process for all those. Then down here I have the equation. You're going to find f as a function of a, and your instructions tell you how to do that. And I have a place for the results from number 9, step 9, 10, and 11. So when I check your lab notebooks, it should take me about 10 seconds to see that it looks exactly like this, and I can see your work. There's not a lot of work that we have to do here. You only have to show the numbers for the first row. If you want to write down other numbers, that's fine, but this is a minimum that I expect to see. Good luck in your lab.